In this video, I want to have a look at how we can find the side lengths of right-angled triangles using trigonometry. So to start off, I just want to refresh our three main trig ratios. So if we've got a right-angled triangle here, if we label one of our angles theta, then we can label our sides of our triangle in relation to that angle. So the angle opposite that side is called our opposite side, and the side next to it is called our adjacent side. The side that's left this longest side and the side that's opposite our right angle is called the hypotenuse. If we were to look at this angle instead, then our opposite and adjacent would be reversed. This would be our opposite side over here, and this one next to it would be our adjacent. Now, if we're looking at those three, we have three trig ratios. So our first one is sine of theta is equal to the opposite over the hypotenuse. Cos of theta is equal to the adjacent over the hypotenuse. And tan of theta is equal to the opposite over the adjacent. So those three trig ratios are comparing two of the side lengths in any right-angled triangle. Now the shortcut to remembering those three is the word SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So let's have a look at how we can use those to find side lengths. So our first example, we have a right angle triangle here with an angle of 62 degrees, a side length of 100 meters, and another side length here that we're trying to find. So from this angle, this 100 meters is our adjacent side, and this one that's labeled x is our opposite side. So the ratio that involves the opposite and adjacent is tan. So we'll write down that ratio of tan theta is opposite over adjacent. And then we're going to fill in what we know. So our theta is 62 degrees. So we're going to have tan of 62 degrees. It's equal to the opposite, which is x, over the adjacent, which is 100. Now, if we're trying to figure out what that value of that x is, we're trying to get it on its own on one side of the equals sign. So we're trying to get rid of this divided by 100. We're going to multiply both sides by 100. So we'll end up with x equals 100 times tan 62 degrees. And if you pop that in your calculator, often questions should tell you what to round to. In ours, we're just going to round to 2 decimal places. So rounding your answer from your calculator to 2 decimal places, you'll end up with 188.07 meters. Okay, our second example, we now have an angle of 70. Our opposite side is 25 centimeters. And our hypotenuse is x centimeters. So opposite and hypotenuse is sine. So we have sine theta is opposite over hypotenuse. That means that sine of 70 degrees is equal to opposite was 25 and the hypotenuse was x. So this question's a little bit different because we've ended up with our unknown in the denominator. So to get rid of that being down there, we're going to multiply both sides by x. So we're going to have x times sine 70 is equal to 25. And then we're going to have to divide by sine 70 degrees to get that x on its own. So we'll have x equals 25 divided by sine 70 degrees. And if you pop that in your calculator, if we round for this question to 1 decimal place, we'll end up with 26.6 centimeters. So that's the length of our hypotenuse there. So those are two examples of finding side lengths in right-angled triangles using trigonometry.